Today we're going to be looking at writing equations of ellipse. So these will be your instructions in order to write an ellipse equation. Oops, I forgot the I. Write ellipse equation. Okay, so the first thing we want to do is look at an example of how we're going to go about doing this. So if I tell you that the center is at negative 4, 0, the vertex is at 2, 0, and the co-vertex is at negative 4, 3. The first thing we want to do is we want to graph this information so that way we can go ahead and write our equation. So if we go ahead and graph what we're given, draw a graph over here. We've got our center at negative 4, 0, 1, 2, 3, 4. Here's our center. We have a vertex at 2, 0. Whoops, just kidding. 2, 0 is right over here. Whoops. 2, 0 is right here. Let me erase this mark. Then we have, and I'm going to go ahead and label this a vertex so we remember later. Our co-vertex is at negative 4, 3. So here's our co-vertex up here. Okay, so what we need to do is we can then map this. Because we know our ellipse is symmetrical, we're going to go ahead and reflect these points. So it'll be up here at positive 3 and then down here at negative 3. Oops. Down here at negative 3. We're over 1, 2, 3, 4, 5, 6 units to the right. So it'll be 1, 2, 3, 4, 5, 6 units to the left. Will be the rest of my ellipse. So here's our ellipse. Whee! Oops, I missed that point, but you know how that goes. Okay, so we're going to write our ellipse equation. It's always a fraction plus a fraction equals 1. Because this ellipse is more horizontal than it is vertical, we know this is a horizontal ellipse, so our x term is going to lead and our y term will come second. On the top is always where we put our center. So since our center is at negative 4, 0, on the top we'll have x plus 4 squared. Our y value is 0, so instead of writing y minus 0 squared, we're just going to write y squared. The next thing we need to do is we need to look at what goes in our denominators. So under x is always the distance from the center to the right squared. So if we look at the distance from the center to the right, that is 6 units. So under x, we're going to take that number and square it. So we'd put 36 under here. So remember, under x, so we'll write off here to the side, under x is center to the right, and then you're going to square that. Under y, because y is a vertical distance, under y we're going to do the center up squared. So from my center up is 3 units. If I square that, that's going to go under my y. So under y is center up, and then we will square that number is what goes under my y, and it's always equal to 1. So if you think about if you were to work backwards or work from this equation, you would look at the equation and you would say my center is at negative 4, 0, which our center is at negative 4, 0. You would say go right and left 6. Well, if we go right 6 and left 6, we get those vertex points. And then we would look at the 9 and say that's under y, so it goes up and down 3, which is what our ellipse does. So you've written your equation and you are done with that problem. The next one we're going to look at is when I'm giving you a vertex or your vertices and the foci. This is going to change it up a little bit, so you're really going to want to pay attention here. So let me switch colors. If we are given our vertices of 2, 5 and 2, negative 7. Oops, I forgot the 2. 2, negative 7. Hold on, sorry, I'm having problems. 2, negative 7. There we go. And we're also given the foci of 2, 2. And 2, negative 4. We want to go ahead and graph these so we can kind of get an idea of what our ellipse looks like. So if we graph it, we have vertices at 2, 5. So 1, 2, 1, 2, 3, 4, 5 would be one of my vertices. And 2, negative 7. So 2, 1, 2, 3, 4, 5, 6, 7 would be my other vertex. And then our foci are at 2, 2 and 2, negative 4. 1, 2, 3, 4. Okay, so we know this is a vertical ellipse. Since my vertices are aligned in a vertical fashion, this is going to be a vertical ellipse. So we know when we have our fraction plus our fraction equal to 1, we're going to lead with the y term, and our x term will come second. Because it's going vertical, we'll lead with that y term. The same sort of things always apply. Well, first let's find our center, and then we'll talk about our denominators. So we need to find the center. The center is always directly in between your vertices. It's also in between your foci, so you can count or just visually look and see that our center is right there, which would be the point 2, negative 1. So we know our center is 2, negative 1. So we're going to go ahead and plug that into our equation. So our center is at 2, negative 1. The y value goes with the y, so that would be y, and this one is x. So we're going to have y plus 1 squared and x minus 2 squared, remembering to always change those signs. The next thing we want to look at is, so the first thing we did, let's kind of give ourselves some steps, is we plotted information, plot points. Step 2 was we found center. The third thing we're going to do is find center and plug in. The third thing we're going to do is find center to vertex, and we're going to square that number. So the distance from my center to my vertex, in this instance it goes up because we have a vertical ellipse, so we're going to count that distance, which is 1, 2, 3, 4, 5, 6 units. So that distance is 6. Because that's a vertical distance, it's going to go under my y. So 6 squared is 36. Okay, so we found the center up. That's under my y, which is 36. The next thing we're going to do is under x is from the center to the right. However, we weren't given our covertice points. We were only given the foci. So because we don't know that covertex, we're going to use foci to find b. Now, we know from before, we know that c squared, our foci equation is c squared equals a squared minus b squared. However, we know c and a, so we're going to rearrange this equation in order to solve for b. So we're going to rearrange this. I'm going to add b squared to the other side and then subtract c squared. So we'll have b squared equals a squared minus c squared. We know this has to be a positive distance, so it's going to be the longer distance minus the shorter. So it's the vertex distance minus the foci distance squared. So the vertex distance squared minus the foci distance squared will equal our covertice distance squared. So in this problem, let me switch colors so we can see what we're working with here. So in this problem, I'm going to do this information in green. So we will see that the distance from my center to my vertex is 6. So we've got, here's our b squared equals a squared minus c squared. So b squared equals 6 squared minus the distance to our focus. So if we look at the distance from our center to our focus, that distance right here is 1, 2, 3 units, so minus 3 squared. And then when we go ahead and work through and solve this, we're going to see that we end up with b squared equals 36 minus 9. So b squared equals 27. We know that in our equation, we always put that distance squared underneath y. So this b squared is 27. That's actually the number that goes underneath my x. In order to finish that, then we will go ahead and square root it, so we know that b is equal to about 5.2. So if we take the square root of 27, which is 5.2, that's going to help us finish our graph. So we know we'll go to the left and right, 5.2. 1, 2, 3, 4, 5. We're going to pretend like it fits over there. 1, 2, 3, 4, 5, and a little bit. And then you can finish drawing your ellipse, such as that.